Okay, good afternoon everyone. So today we are going to discuss about the engineering graphics. So myself Dr. Thirumurugan, Associate Professor, Department of Mechanical and Automation Engineering, PSN College of Engineering Technology. So what's engineering graphics? So technical drawing is the language of engineers and designers. So these drawing for only, not only for the architecture. So all the domains it needs language. That language is a drawing. Okay. So next, it's a very important for the engineering graphics. So first thing is a freehand drawing. What's a freehand drawing? So the line or a sketch, whatever it is. So anything maybe drawing with without help of the tools, which means scale, drafter, compass, to develop some geometries which called as a freehand drawing. So these are some example of freehand drawings. Next, instrument drawing. So the instrument drawing is to develop some drawing with the help of some tools, scale, compass, drafters, some other extra tools. We are going to use some drawings. This is called as a instrument drawings. So compared to freehand drawing, so this is a rough hand sketching. So this is exact dimensions, proper drawings. So this is an example of instrument drawing. So next one is the advanced level of drawing. So which means the computer, with the help of the computer aided tools, we are going to develop the drawing, which means the computer drawing. So some of the peoples develop the drawing with the help of some platforms. So what's a platform? The AutoCAD, SolidWorks, Pro-E, CATIA, some other softwares with respect to the drawing. So this is an example of a computer drawing. So the left side images is the people's to develop the image with the help of the AutoCAD software. So next, most important thing of the engineering drawing. So what does that means? Elements. The main elements followed in the engineering drawing. So what's the elements? So there are basic two elements mainly thing followed in the engineering drawing. So first one is a graphic language and second one is a word language. What is that? What's a graphics language and what's a word language is? See the image. So the red color indication is the graphic language and blue color, which means which one is I have rounded. The rounded is the word language, which means the graphic language is the circle or triangle, square, rectangle. So all the things comes under the graphics language. So the word language is how much diameter we drawn, how much dimensions of a rectangle we drawn. So the dimensions, how much diameter, how much length, how much thickness. So all the things mentioned in the word language. So without graphic language, without word language, we can't proceed the drawing. So next, the line in the graphics language, combination of line type, projection method and geometric constructions. So the word language combined with the lettering alone. Next, drawing sheet. So these all are the basic things known about the as engineers. So see the drawing sheet categories. So first one is classified into the A4 sheet. So the A4 drawing sheet is known as everyone. So next category A3 sheet, next A2 sheet, next A1 sheet, next A0 sheet. So the ISO standard sheet, these sheets set in the ISO standards. So what's the 210 and 297? So this dimension is the length and breadth of the drawing sheet. So the A4 sheet is 210 into 297. So 210 is the length width of the paper and 297 is the length of the paper. So A3 sheet is a 297 into 420 mm. So these values are the mm, which means millimeters. So 297 A3 sheet for the A3 sheet, 297 mm breadth and 420 mm length. And A2 sheet is 420 mm width and 594 is the length of the A2 sheet. And A1 594 into 841 mm. And finally the A0 sheet is the largest one. 841 mm width and 1189 mm length. So next, orientations of the drawing sheet, which means the basic things followed in the drawing sheet. So they should be everyone known the orientations. So the first one, the blue color indication is the sheet, drawing sheet or outermost edge. Next, the people are going to develop the margin, which means the border line. Next, to develop the title block. Okay, so the instant of gap, which means that is inside the border line, we have to develop the drawing. So next, this method common to A0 to A4 sheet. If suppose the peoples are rarely used in the A4 sheet, means the paper going to change in the portrait. So next, the margin dimension. So D is the left side margin and C, top C, bottom right side C and bottom C is the uniformly followed. What's the dimensions of the margin is mentioned here. So A4 sheet means our C is the 10 mm, D is the 25 mm. Sorry, this is a printing mistake. It's not a minute, it's a mm. And A3 sheet followed in the C space is 10 mm and D space is 25 mm. And A2 is similar to the A3 and A4. So C space is 10 mm and D space is 25 mm. And A1 and A0 is something different from the A2, A3, A4. So 20 mm is the C space and 25 mm is the D space. So this is a simple example of a drawing sheet which is developed from the some other institution, some other industries. So this is a typical drawing sheet of the output drawing sheet. So the people are mentioned the C space and D space and also develop the title block and instant the drawing space. So next one is the main thing, drawing scale. So the scale is the ratio of the linear dimensions of the element, whatever draw the elements, circle, square, whatever it is, and the object should be drawing to the real linear dimensions of the same element of the object. So the linear dimension which represent the length and the size of the shape. So the image, so left side is the drawing image, drawing sheet, whatever the to develop the image in the drawing sheet, and the right side is the actual size. What's the actual size means? Actually the image is 1000 mm. Okay, so imagine the actual size is 1000 mm means we can't draw the 1000 mm in the drawing sheet. What we are going to do means we are going to introduce the scale, which means the 1000 mm converted into 10 mm. So the scale is represented as 1:10. So this is the understandable one. So 1000 mm we can't develop the 1000 mm into the drawing sheet. So instead of 1000 mm we can able to draw the 10 mm. So 10 mm equal to 1 is to 1000 means it is easily understandable 1. So next is the line. So everyone basically know the lines. So instead of the lines, the engineering drawing classified into various categories of the lines. So first one is a continuous thick line. So the continuous thick line is mostly used in the main diagrams. So this line is a visible line. Second one is a continuous thin line. So the thin line we are going to use the dimension line, extension line, and then leader line. So next one is a thick line. So which means the hidden lines are used this kind of a line. So next one is a chain thin line. So the chain thin line, the people are using the center line of the object. Okay. So I will show the last in the lines. So visible lines. So visible lines definition is represents features that can be seen in the current view. So next one, hidden line. So hidden line is represent the features that can't be seen in the current view. So visible line is we can able to see, but hidden line is we can't able to see. So next one is a center line. So center line is represents the symmetry, path of the motion, center of the circle, axis of the asymmetrical parts. So these categories represent with the help of the center line. So next one is a dimension and extension line. So see the image. So first one is a visible line. So the visible line, the main diagram represent with the help of the visible line. So next one is a hidden line. So the hidden line is invisible areas. So see the hidden portions. So first line, second line, third line. Again the smaller circle. We can't see the circle on the front view. So the front view drawing with the hidden line. Next one is the center line. So whatever it is, so to draw the rectangle box or a circle, it need some center line. So the center line draw the center line axis. Okay. So next one is a dimension line. So dimension line is how much length it have the geometry, how much thickness, okay, how much diameter it have. So all the things mentioned with the dimension line. So next one is a cutting plane or a viewing plane line. So we are going to see the cross-sectional view. The people are using the cutting planes. So next one, short break line. So short break line means So total solid image is different. The cross-sectional view is different. We can show with cross-sectional view of solid image and cross-sectional view with the help of the short break lines. So long break line similar to the long break line and section line. See the image of some example of dimension line, extension line and leader line and center line. So this is a typical image to show the all the line examples. Okay. So the thick line, the major thick line is a visible line and dimension line is a 50 mm. They represent the line is dimension line. So from where to where? Okay. So here the center of this circle to the center of this circle is 50 mm. So where to where? The represent with the help of the extension line. So next the leader line is very thin line. So the leader line sometimes represent the radius of the curvature. Okay. The center line also known. So next, traditional drawing tools used to develop the drawing. So T-square and triangles and adhesive tapes and pencil. So here we are going to look into the various kind of pencil. So generally the papers are only the HP pencil, but we using the 2H pencil and 3H pencil and 4H pencil. Dimension line we are going to use 2H pencil. So extension line we are going to use 3H pencil. So the main diagram developed with the help of the HP pencil. So next sandpaper, next compass, pencil eraser, erasing shield, circle template and tissue papers, sharpener, clean paper. So these are basic tools we are using the drawing. So next, going to notations which followed in the projection of points. Okay. So following notations will be followed in the while naming different views in the orthographic projections. So before going to see the projection of points, so totally two views is very important. So first one is a top view and second one is the front view. Okay. So if you are going to use this top view and front view, we need some vertical plane and a horizontal plane. Okay. Because the top view projection is going to located on the horizontal plane. Okay. So the front view projection is located into the vertical plane. So top view, for example, if you are using the A point, particular A point, so top view means it's denoted with small letter A. Okay. If you are using the front view, the particular point denoted as a dash. Okay. So this only for the point. If suppose we are going to draw the AB, a straight line means the top view it's located into the horizontal plane with the help of the denoted as a small letter A and small letter B. So the front view is small letter A dash and small letter P dash. So see the vertical plane. So already I told VP. So the blue color sheet is the vertical plane. The biscuit color, the horizontal line is a HP and vertical plane denoted as a VP. Okay. So before going to see projection of points and projection of lines, so usually the people are follow the common reference. Okay. So the common reference is the followed in the here. The common reference is developed with the help of the vertical plane and horizontal plane. Okay. So the XY is the midpoint of the vertical plane and the horizontal plane. So this is the first quadrant, second quadrant, third quadrant, and next one is the fourth quadrant. So see how to classify it into the fourth quadrant, how to easily find out the fourth quadrant mean. It has some reference I already told. So common reference followed in the universal. Okay. So how to find the first quadrant, how to find the second quadrant means here if suppose our point or lines is located in the first quadrant means it have some reference, common reference. What is that means? Above HP, vertical plane in front of VP means the particular point or a particular line is located in the first quadrant. Okay. If suppose the particular point is located in the second quadrant means the HP above HP behind VP means it's a second quadrant. Third quadrant is below the HP behind the VP means it's a third quadrant. And fourth quadrant is above the VP below the HP means it's a fourth quadrant. Okay. So the observer, for example, we are going to stand here. Observer here. Okay. So our vertical plane is represent the front view. Okay. So top view is represent to the horizontal plane. Okay. See the graphical representation of the 2D image. Okay. First quadrant, second quadrant, third quadrant, and the fourth quadrant. So we are going to see some example of first quadrant point, second quadrant point, third quadrant point, and the fourth quadrant point. Okay. So first one is HP and VP. So point is this point is located in the first quadrant. Okay. So the point called as A. So observer first initially the observer standing here. So the A, which means the front view A is denoted as a dash. The A dash located in the vertical plane. So next we are going to use the top view. So the particular A is the projection is located on the HP horizontal plane. So the particular point A point with respect to the vertical plane means A dash. With respect to the horizontal plane means A. Okay. So next, so the point is located in the second quadrant. Okay. So the A point front view is vertical plane and top view is horizontal plane. Okay. So next, third quadrant. So third quadrant similar to the front view is A dash, the vertical plane, and small letter A is a horizontal plane. So next, fourth quadrant, the particular A is A dash, located in the vertical plane, small letter A is located in the horizontal plane. Okay. So next, going to see about the straight line. Okay. Here our previous topic, projection of point. So projection of points, whatever we can be able to see, the particular point is, if you using the front view, if you are using the top view, the particular point able to see the particular point. Okay. But here the straight line may be changed based on the views. Okay. So what is that means? These all are possible cases to locate on the particular lines. So first case, the vertical line, which means a line is perpendicular to HP and parallel to VP. Okay. So next, line parallel to both the HP and vertical plane. So next, line inclined to HP and parallel to VP. Next line is inclined to vertical plane and parallel to HP line. Next, line is inclined to both HP and VP. So see the image. So first case, a line is perpendicular to HP and parallel to VP means, so see the VP and HP plane. So this is a XY line. The particular line, a line is perpendicular to HP. So HP perpendicular and parallel to VP means the line is actual dimensions of the line. If you using the front view, AB line is projected into the vertical plane. So in the capital letter AB is denoted as a small letter A dash and B dash. So next we are using the top view. The particular line is located onto the HP in the single particular points. Okay, so similar A and B is the located here. Okay, so this is the first case, and second case is a particular line is parallel to HP and parallel to VP means how to draw this case means, so this line, so this is the position of the, so this line AB is parallel to HP and parallel to VP. So initially we have applied the front view, so A dash and P dash is projection of front view. Next we are going to apply the top view. This top view projection is located on the HP, which means this is the A and B. So this is a 3D view. So how to draw the pictorial representation means photographic projection. So this is a 2D image of first case and this is the second case. Okay, so we are going to draw the drawing sheet using the orthographic pattern alone. So the pictorial representation is only for our understanding only. Okay. So next, third case, a line is inclined to HP and parallel to VP means, so inclined to HP, so somewhat inclined from the HP and parallel to same distance of the B and same distance from the A. Okay. So these are orthographic projections. Okay. So next, fourth category, a line is inclined to VP and parallel to VP means, C. So VP somewhat inclined from the A and somewhat inclined from the B. Okay. So this is the orthographic projection of fourth case. So next, fifth case, the line is inclined to both HP and VP. So what is that means? It is somewhat inclined from the VP and somewhat inclined from the HP. Okay. So the alpha is somewhat inclined from the HP. So the beta is somewhat inclined from the VP. So how to draw the pictorial representation, which means orthographic projection is, so alpha and beta is with respect to the VP and HP angle. Okay. So this is the example of inclined both the HP and VP line. Okay. So next we are going to see about the solids. Okay. To understand and remember the various kind of solids, okay, in the subject properly, those are classified and arranged in the two major groups. Okay. So group A and group B. So what is the group A and what is the group B means? So solid having top and base of the same shape means it is a group A. Okay. Top and bottom is similar to same geometries. Okay. So this is a group A. So what's a group B means? Solid having a base. Okay. Solids having the base, some shape and just a point as the top. Okay. It's a somewhat different from the group B because the base, it has some base, okay, some top is particular, it's a focusing on the particular point, okay. So I will show the example. So group A, it's an example of the cylinder, okay. See some other examples. So triangle prism, square prism, pentagonal prism and hexagonal prism. So the prism and cylinder comes under the group A category, okay. Cube also. Next the cone, okay. Cone, pyramid comes under the group B categories, okay. So triangle, square, triangle pyramid, square pyramid, pentagon pyramid and hexagonal pyramid. So these categories comes under the group B. So we can able to see the difference between the prism and the pyramid. So here the prism is bottom and top, similar geometry and similar dimensions. Here the pyramid is bottom is some other shape, which means square, it may be pentagon, it may be hexagonal. What about the top? It's a single similar point, okay. So this is a pyramid, okay. So next we are going to some other key points. What's followed in the develop the prism, develop the pyramid and develop the cylinder and develop the cone. So see the points. So this is a top face, this is a rectangle face, this edge is longer edge, this is corner of the base, this is the edge of the base, this is a base. So this is called square prism, followed on the key terms. So next is the pyramid. So pyramid, the topmost point called as a apex point. This is a slanting edge, this is a base, this is the edge of the base, this is a corner of the base, triangle face, okay. So what see in the light thin line. So this thin line called as a imaginary lines, okay. So next the base of the cylinder, next apex point of the cone, next base of the cone, okay. So next the outermost edge, the cylinder and cone called as a generators. These all are some example of the section of solids, okay. These all are some example of prism and pyramid. So triangle prism, the first one image is triangle prism, and pentagon prism and rectangle prism, okay. And here the second one, first image is square pyramid, pentagon pyramid, and last one is a hexagonal pyramid. So these all are a example of solid, prism and pyramid. So next, standing position of the particular solid. So what is that means? The pyramid, okay. So the pyramid is standing on HP means the first image, okay. So the axis, in addition to that, the axis is perpendicular to HP and parallel to VP means the particular solid front view, it's look like this, okay. So second case, what's the second case means? Resting on HP, okay. In addition to that, one of it's a point, the base circle is resting on HP means it's look like a second case, okay. In addition, the axis of the pyramid is inclined to HP means we are going to draw like this, okay. So next, lying on HP, which means one of the generator is lying on HP means we are going to draw the third case, okay. Similar to the top view case. So we are going to see the problems. So what's the problem is a square pyramid. Base side is 40 mm and axis height is 60 mm. Has a triangular face on the ground. On the vertical plane is containing axis makes an angle of 45 degree with the VP. Draw its projections. So this is a question. So next we are going to how to draw the problem, how to draw the geometry. So first step to draw the XY line. Okay. So next to draw the square pyramid. Square pyramid of top view is 40 mm. Okay. So this is a square top view. Okay. So next give the name of each corner A, B, C and D. Okay. So next O point. O point is a topmost point, which means the apex point is the O point. Okay. Next to draw the extension line from the outermost edge of the square. So here and here. Okay. Next to draw the center line which develop from the O point. So the center line which contains only the 60 mm long. Okay. So from the XY line the height is the O is 60 mm long. Okay. So the A dash and P dash is front view of the pyramid and C and D is second outermost edge of the pyramid. Next, the already question mentioned the axis line. So one of the triangular faces on the ground. So O, C, D. So I have taken the OCD triangle face. And this triangle face is lying on the ground. So OCD. So this face is lying. So next, how to draw the A and B means here. So here to take the measurement from the C to A. Okay. So from here to cut the arc. Okay. From here. Okay. Next, take the measurement from the O to A dash and P dash. Cut the another arc from the O. So here to cut the another arc. So this point is A and B. So next, join the C to A and then A to O. Okay. So this is a line on the ground. So next, all the points to draw the extension lines. Okay, from the third step. Next, from the step 1. Okay, from the step 1 we are going to draw the extension line. Okay, so next meet out the horizontal line or vertical line to give the name. Okay, so see your horizontal line and see your vertical line to meet out here. We put the C point here. Next, we put the P point here. So P horizontal line, P vertical line, vertical extension line. We put the P here. Next, similar to the C, similar to the A. So next, A O horizontal line or vertical extension line. We put the O here. So this is a simple to projection of the solid. Okay. Thanks for listening my lecture. Thank you. If you any doubt, any queries, you can contact. I will give my email ID or WhatsApp number. You can ask anytime. Okay. Thank you.